Parallax is the name given to change in the position of an object with respect to the background when the object is seen from two different positions. That is what I told. Distance between the two positions is called basis. That means distance between the eye position, 2i, distance between 2i. It is called basis. So, what is the question related to that? What is parallax? What is meant by parallax? Explain. So, you can explain that. Then parallax method, how we can use it to find the distance of a star from Earth. Now it is 33. 13 മിനിറ്റ് കഴിഞ്ഞപ്പോഴാണ് ഒരിടത്ത് വരുന്നത്. Okay.
Good morning, ma'am. Connection problem ആയ കാരണം ma'am.
ആണോ? Okay. No problem. We just started. We were discussing yesterday's portion. Okay, listen. So we are studying parallax method now. Parallax means when we observe an object from two different positions. I will show this figure. See, A and B are two positions on Earth. For example, two observatories on Earth. Two observatories on. What is the purpose of observatory? To observe planets, stars, study that. Observe and study the behavior of planets, stars, etc. That is observatory. Suppose A and B are two observatories on Earth. And we observe a star, distant star. We have to find out this distance from Earth. What is the distance of the star from Earth? That is what we have to find out. So, what we have to do? We should know this angle. This is the parallax angle. We should know parallax angle. How will you find parallax angle? For that, first you observe a star. Not the star whose distance is to be measured, other star whose position is found to be just above his head. That means directly when he look up, we can see a star. That star is observed first. Okay. Then he turned the telescope to view the star whose distance is to be measured. So this is theta 1. This angle is theta 1. So this also will be theta 1. Similarly, from the other observatory also, he observed the same star which is directly above him. Then he turned the telescope to view this star. So this angle is theta 2 and this will be theta 2 because these are two parallel lines. This intersecting line. So these angles will be equal. So if this is theta 2, this also will be theta 2. If this is theta 2, this will be theta 2. So this angle, now we got theta 1 plus theta 2. That is parallax angle. Theta 1 plus theta 2, that is theta, is the parallax angle. Now we got what all things? Theta we got. This distance we know because this is the distance on the surface of the Earth. Only unknown distance is this capital D, which is the distance of star from Earth. Okay. So how will you calculate that? Angle equal to arc length by radius. When the star is at a very large distance from Earth, this can be taken as a circle. See, you can draw a big circle here with the sun as center, and this will be the arc length at that time. This will be the arc length, AB, arc length. So, angle equal to arc length by radius, B by D. Angle equal to arc length by radius, B by D. See children, if you find difficult, watch that video. So, everything is explained in that. So, you will understand it properly. Watch the video which is put in our physics class. Physics class group, I think you have joined. Any difficulty, you watch that. And still, if you find difficult, you can call me. Video call, I will explain to you. Okay? If you, after watching the video, if you find it difficult, call me. You have to see what way, finally what you have to find out. Capital D you have to find out. Angle equal to arc length by radius. Arc length B. Radius is capital D. So theta equal to B by D. Therefore capital D equal to B by theta. So if a question comes, explain parallax method to measure the distance of a star from Earth, all these things you have to write. I have given that notes. So you can write the question on the top of the, near to the heading, you can write the question. You are having the pencil with you, you are having the notes, you can write the question, pencil, with pencil you can write. Explain, what is parallax? How will you measure distance of a star or a planet from Earth by parallax method? Children, you can write that. What is parallax? That answer is here. And how explain how will you measure distance of a star from the surface of the Earth? Okay, by parallax method. I think you understood, children.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Still you feel difficulty after the class, you watch the video. Okay. The next is, see, diameter of moon. How will you measure diameter of moon from the surface of the Earth? So this is a point on the observatory, Earth. This is our Earth where we live, and this is an observatory on the surface of the Earth. With what is needed to view a distant star or planet? Which instrument is needed, children? Distant object. To view distant object. Which is
Telescope.
telescope. Telescope is needed. So observatory, we can see telescope. Have you seen telescope in any of the observatories after going there? Have you seen through a telescope? Anyone? Microscope ഉണ്ടല്ലേ ലാബിലില്ലേ microscope
Yes, teacher.
I use.
telescope. What about telescope? Have you viewed through a telescope?
I have
Yes.
viewed.
Yes, very good. So you will get an enlarged view, isn't it? Enlarged view. When we look the planet now from here with our naked eye, we cannot see clearly. There are only some circle like that we are seeing. But when we use a telescope, we can see the details. Because enlarged version we are getting in a telescope. Small object get big. That means distant object is brought near to us. In a telescope, very distant object is brought near to us. So clearly we can see the things. Its diameter and see that full view we are getting. So when the surface of the Earth, O is a point on the surface of the Earth. First you see in the telescope, you will get the disc shape image. When we look through a telescope, you get a disc shape image of moon. Then first focus at the point A, then turn the telescope to view the diametrically opposite point. So first what you have to do with the telescope, first observe this point A. Then you can turn the telescope to view diametrically opposite point, not any other point. Diametrically opposite point is observed. Then you can see that how much angle you rotated, telescope is rotated. How much angle it is rotated, that you can measure in a telescope. How much we turn the telescope to view A and B, that is alpha. Let us take that as alpha. Diameter of moon is what we have to measure, small d. Okay. Then this distance we actually calculated, distance from Earth to moon, Earth to planet, that we have calculated by some parallax method we have calculated. Now with this alpha is known to us, capital D also we know, the only unknown distance is small letter d. So same formula we are using, angle equal to arc length by radius. This is the radius now. When you draw a big circle, this becomes the arc length and this becomes the radius. With OS point, you draw a big circle with OS center capital D as radius. If you draw a circle, you will get AB as the arc length. So arc length by radius becomes angle alpha. So that formula is used here. So you can see angle equal to arc length by radius, small d by capital D. Therefore, what is our aim? We have to find small d, diameter. Diameter equal to alpha d, cross multiply. Alpha d, diameter equal to alpha d. So, this is another method to measure diameter of moon. So, what is the question related to that? Explain a method used to find diameter of moon. Like that question comes. Size or what is written? Angular diameter of the planet or moon. Size. What is the question? Explain. You just add explain. Explain a method to measure size or angular diameter of the planet. This is
Should we read this question? Explain the size of.
Explain a method to measure size or angular diameter of planet or moon. Explain a method. This is an indirect method. Actually, it is not a direct method, indirect method. Explain a method used to measure size or angular diameter. Angular diameter. This is angular diameter of the planet or moon. Okay, got the question now? So after writing the notes, I will tell the what question may come from that part. So you can just write with a pencil. But then if that question come, first what you have to do? Draw figure, angle alpha mark, small d diameter mark, capital D distance of the point O from the from Earth to that planet. Distance, capital D is the distance from Earth to that planet or moon. So all these things you have to mark. After marking, what you have to do? You have to explain. What is angle? It is alpha. Alpha is the angle subtended by the two directions. See, first is OA, first position. Then it is rotated to view the point OB. So these are the two directions of observation of the diametrically opposite points of the moon from Earth. So what is alpha that you have to write? All these are explanation of this figure. So first draw figure and figure explain which letters you used here, that you have to explain. Capital D. What is capital D? It is the distance of the moon from Earth. Capital D. What is small d? Diameter. If you find difficulty in writing all this, you just write capital D, distance of Earth from moon, small d, diameter of moon, alpha, it is the angle subtended by the two diametrically opposite points on the surface of the Earth. Like that, you can explain. That method also you can use. Then finally you should obtain this formula, angle equal to arc length by radius. Then you put that in a box. This is with that we have to do problems, very important. So this is our final equation, diameter equal to alpha d. Understand? So understood how to write the answer, children?
Teacher.
Okay. So first what you have to do? First you have to study. Then take a book and write. Without looking these notes, you just write. Diameter of moon, what all things you have to write. First to draw figure, then you have to explain what all letters are used in figure, and you should obtain the final expression. Okay, diameter. Okay, this is the way of writing. Now see, 11th and 12th, you know, in one chapter itself, so many derivations you have to study. So many derivations, and all derivations, finally you get one equation. So many things to remember. So first equation we studied, parallax method, and then diameter equation we studied. Now two equations we have studied. No. Next, calculate. This is one problem. Before that, I will explain that oleic acid method. Okay, this is problem. Before doing problem, I will explain that how to measure the diameter of or size of molecule of oleic acid, whether it is open now. No. See, this is oleic acid, children. Not opening. Just wait for a few minutes.
Acid as 400th part of the solution.
Plans inevitably change. With Roadmaps and Jira software, quickly adapt and adjust to changing
Powder on its surface.
Okay. Okay, children.
20 cc of alcohol oleic.
See, next is to measure the size of molecule of oleic acid. That's also very important experiment. See, it is an indirect method to measure the size of molecule. Molecule, you know, very small in size, and only microscope can be used to measure it. But you know, without that, we are measuring the size of the molecule of oleic. We are not using microscope to measure the size of the molecule of oleic acid. That is an important experiment. So for that, what all things are taken? You look here, all of you listen well. Video is also put in that group, but I think I can explain it here also. So take oleic acid. Why oleic acid is taken? Because compared to other acids, molecule of oleic acid is bigger. Bigger means 10 raised to minus 9 only, children. Very small, but compared to other molecules of other acids, its size is bigger. See, 10 raised to minus 9 meter only. 10 raised to minus 9 means 1 by 10 raised to 9. 1 by 10 raised to 9, see such a small quantity is this. So, what we are determining it, you can see how. So, 1 centimeter cube of oleic acid is taken in a beaker. 1 centimeter cube. Then it is mixed with alcohol. How much? 19 centimeter cube of alcohol is mixed with. Then we get a solution. Oleic acid, alcohol, solution. And in that solution, what is the concentration of oleic acid, children? Muhammad Asif, can you tell what is the concentration of oleic acid in this solution? Total, how much is this now? 1 plus 9.
20 centimeter cube, teacher.
Total is 20. What is the concentration of oleic acid in that 20 centimeter cube?
1 centimeter cube.
So we can write concentration of oleic acid is 1 by 20. Out of 20, 1 part is oleic acid. So 1 by 20. Clear, children? This equation? Concentration of
Yes,
oleic
teacher.
acid 1 by 20. Okay. The next step, what we do? Let us see.
Oleic acid solution with 1 cc of oleic acid in it. And dissolve 1 cc of this solution in alcohol.
Now we got 1 by 20 centimeter cube of the solution. In that, from that again take 1 centimeter. So we already made a solution of oleic acid and alcohol, and in that solution the concentration of oleic acid is 1 by 20, and that solution is taken. That solution is taken, 1 centimeter cube of that solution is taken and mixed again with the 19 centimeter cube of alcohol and made another solution. That means we are diluting it, diluted, again diluted. First diluted with alcohol, then we made a solution, then that solution is again diluted. Now, what is the concentration of oleic acid in that? Already it is 1 by 20. In this 1 by 20 centimeter cube of oleic acid only is there. Again it is diluted to make it 90 centimeter cube of oleic alcohol is added, and we made another solution, diluted solution. And what is the concentration of oleic acid in that? Children, can you tell anyone? Now what is the concentration of oleic acid?
1 by 40.
1 by 20 itself.
1 by 40 അല്ല 20 into 20 വരും.
അങ്ങനെ ചെയ്യുമ്പോൾ 1 by
ആ
40.
ആ 400 അല്ലേ വരിക 20 into 20 എന്ന് പറയുമ്പോൾ 400 അല്ലേ 20 into 20 into 2 ആണ് 40 20 into 20 it will be 400 okay so what is the concentration of oleic acid in this solution now children 1 by 20 1 by 400 one part out of 400 part of the solution only one part is oleic acid 1 by 400 is the concentration of oleic acid now that means very much diluted it is. Then what is done? Let us see. Then what is done? Take. I will show you that. What
to
is done?
dilute it to 20 cc. This makes the concentration of oleic acid as 400th part of the solution. Next, we take water in a large trough and sprinkle.
See, water in a large trough is taken and some lycopodium powder is sprinkled on it. Lycopodium powder will spread uniformly on the surface of water. We can see that.
Some lycopodium powder on its surface. Lycopodium powder is a yellow tan powder that spreads uniformly throughout the surface of water, forming a thin layer. Then, put 1 drop of alcohol oleic acid solution in this drop. The oleic acid drop spreads into a thin, large and roughly circular film of molecular thickness on water surface.
Children, so what is done? The concentration of oleic acid in the solution we have now is 1 by 400 centimeter cube. And from that, few drops, see one drop is put on the water. On the water surface, what is there, children? Lycopodium powder. Why lycopodium powder? That will spread uniformly on the surface of water and a thin layer of that is formed. Thin layer. It forms a thin layer on water surface. What? Lycopodium powder. Okay. Then you put a drop of that solution, a drop. We don't know how much a drop of that solution is put in that solution. It take a circular shape, oleic acid. And you know, from this oleic acid, alcohol will evaporate. Alcohol, when it is kept open for some time, it will be evaporated. Then what will remain here, children? Alcohol plus oleic acid mixture or solution is poured here. And if it is kept for some time, alcohol evaporates. Then what remains? Please tell.
Oleic acid.
Oleic acid only remains. And its thickness, you know, we have diluted it very much and already the alcohol is evaporated.
Listener is waiting.
Yes?
Listener is waiting.
Okay. Waiting. But I am not able to see. Let me see. Okay, listen. Okay. Now how much children? 34 still absentees are there. So it will form a thin layer, molecular thickness. Such a thin layer is formed here. Oleic acid will form into a thin layer of molecular thickness. Molecular thickness means size of the such a thin layer is formed. Its thickness will be of molecular size. Okay. Then what is done? Let us see. Then what is
By pushing away the lycopodium powder from the point where the drop is dropped on the surface. This makes the circular film of the acid drop identifiable on the water surface. Quickly, we measure the diameter of this circular film to determine its area. A. Let the approximate volume of a drop of solution dropped on the surface of water in the trough be V centimeter cube. As the concentration of oleic acid is 1 by 400 in the solution, The volume of oleic acid in each drop of the solution is V by 400 centimeter cube.
See, children, so in this we can measure the volume. This is test tube. We can see how much volume of oleic acid is dropped into the water. That actually we know from measuring. If you have a measuring test tube, we can measure how much volume of oleic acid is dropped into that. So let us take that as V centimeter cube. And in V centimeter cube, how much part it will be oleic acid? Volume of oleic acid in that drop will be V by 400. So V by 400 is the volume of oleic acid of one drop of that solution. Okay, if there are n drops, we can see n into V like that. One drop, it is the volume of oleic acid in that solution. So if it is having n drops, we can write n into like that, n into V by 400. Okay.
Since only one drop of solution is put in the water, the volume of oleic acid on the thin film is equal to the volume of the drop. That is V by 400 centimeter cube. Now that we have the area and volume of the thin circular film, we can get its thickness, T, as the ratio of volume to area. T is equal to V by 400 a centimeter. If we assume that the film is monomolecular, as the concentration is very low, the thickness of film becomes the size of a molecule of oleic acid. We learned how to measure a tiny molecular distance or a massive stellar distance.
Okay, children, this formula I will explain. So we know area into thickness is volume. Area into thickness is volume. See here, this with a tracing paper also we can measure this area with a tracing paper. Have you got any idea to measure this area, children? They may have measured by measuring the diameter, and radius can be calculated pi r square. With that formula, in this experiment, they explain diameter is measured, and then r radius will be diameter by 2, then pi r square will be the area. Can you tell any other method, children, with a graph paper and a tracing paper? Can you tell, children? Anyone? Anyone? For example, graph paper. No idea? With a graph paper, how can you measure? Please, children, anyone?
By cutting the squares.
Correct answer. That means you first put a tracing paper over it, and you get this particular shape, circular shape. Then you keep it on a graph paper, and how much squares it take in that area, how much squares we get in that area. For example, 15 squares. So we can write 15 centimeter square. Half square, 2 half squares will add to 1 like that. So area becomes, for example, 15 squares we got, full squares we got. We can write 15 centimeter square is the area like that. So tracing paper, if you have a tracing paper and a graph paper, you can measure area. Or by this method they told you just measure the diameter and then find the radius, then pi r square you can use to find the area. But actually you no need to explain all this, how we are measuring area. Just write, we measure area with the tracing paper and the graph paper. Measure area, let it be A. Measure area, let it be A. What is the volume of one drop of the solution? V by 400. So area into thickness gives volume. Area into thickness gives volume. Therefore, thickness is volume by area. Volume by area. Area comes in the denominator.